Okay, today we're going to start doing some transformations on the two sinusoidal functions we learned yesterday. So what were the two sinusoidal functions we learned? Remember, sine and cos. So I'm just going to draw like a really quick sketch up here of sine. So if this is the middle of my graph, sine goes up, down, and back, right? And cos. So here we go. Cos starts at the top, goes down, back. So we really need to know those functions. In fact, before I move on, let me just go back and look at the ones you need to learn. Here they are. All right, so that's what we talked about in the end of our last lesson. We got to know these graphs. These are the graphs we're going to do the transformations on. So we really need to know if we're talking about degrees, at 0 degrees, y is 0, 90, 1, 180, 0, and so on and so forth, right? Or in radians. Radians are the measurement around. So remember, full circle, 360 degrees, right? If we're measuring the angle, if we're measuring the length around the outside, it's 2 pi. So this is one circle, and that makes up one period and one cycle of our sinusoidal functions. So sinusoidal functions are functions like sine and cosine, right? They both have the word sine in it. That's why we're saying sinusoidal. All right. So we need to know these. So when we start each of these graphs, this is the table I'm going to start with if I'm starting with sine. This is the table I'm going to start with if I'm starting with cos, okay? And then we're going to do our transformations to them, okay? The other thing, okay, so let's go back to what we were just talking about here. Okay, so back to this. So we are starting with sine or cos. I'm just using sine here. It could also be cos, right? It could be cos, okay? It could be either or. Sine or cos. We'll just use sine for now, though. Same idea. Now, what are our transformations? Remember, it's the same four. Remember we talked about, we've done a lot of transformations this year, right? It's the same four transformations for any two-dimensional function. It doesn't matter what it is. So the good news is you actually technically should know how to do all this, right? But it's been a while, and sinusoidal functions are a little messier because of the degrees or the radians, so we'll go through it. Now, this week, we're only going to we're only going to talk about the transformations that affect the y coordinates, okay? So what are those? Those are A and C. So let's kind of break those down and maybe you want to make some notes on it, right? So the A, right, that is our vertical stretch. Remember that guy? Vertical stretch. And if it's negative, remember how it can cause a reflection, okay? So what do? We multiply y by A. So A times our y coordinates, right? So it's a vertical stretch. We multiply the y coordinates by A. I'm just going to kind of do a little point form here, right? A times y. If it's negative, right, we have a vertical reflection. If negative, we have a vertical reflection. Those kind of things, right? Vertical, I'll just write ref for short. The final thing to know about A is also our amplitude. So if you go back to the earlier lessons there where we really start talking about amplitude, that's what A is. So when you know these things, it makes graphing them really easy. So for what is the amplitude? I'm just going to draw the sine graph here again. So here's sine, just loosely drawn, right? The amplitude is the distance from the middle to the top or the middle to the bottom. That's the amplitude. So whatever A is, that's going to be that distance. That's our amplitude, okay? Amplitude. Okay. The other one we're going to talk about today is C. So we're not going to talk about K, and we're not going to talk about D. Those are the things that affect the x coordinates, right? Those are our horizontal changes, okay? X coords or our horizontal. We'll save those for next week, okay? So we're just going to focus on these two today because these two are the easiest ones, and they'll help you get used to how to draw the graph, how to draw sine and cos, and then once you kind of got that mastered this week and drawn some, we can move on to the x coordinate, and we should be pretty good, and you'll find them a lot easier. If we do it all at once, especially with everyone at home, it's going to be really tough and really messy. So master this first. Okay, so C, what does that do? Remember, that causes a vertical translation. Now, in your textbook or physics class, they also like to call it a vertical displacement. They mean the same thing. Translation, shift, displacement. So I'm going to we're going to use translation, but I'm going to put in brackets displacement because you're going to see that at times. Displacement just meaning moving something, right? So same idea, just a different word meaning the same idea. But in physics, it's really popular to use vertical displacement. Okay, so vertical displacement, it also tells us where the middle of our graph is, because whatever we move up or down, that's going to be the middle. So that's also called the equation of our axis. So the equation of our axis is just going to be y equals c. So that's the middle of our graph. Here, let me just write this down, y equals c. So whatever this is, right here is the middle. Now it starts at 0, but if we move up or if we move down, that's how much c is going to be. So if we move it down, maybe it's down here, right? So for now, we'll just say that's wherever c is. It starts at c equals 0 because it's like having 0 here. There's nothing there, right? That's where it starts, and then you move it up or down from there. Okay? Let's see. Any other details? I guess technically on amplitude, I'm just trying to think on the fly here. When we say amplitude, it's actually the absolute value of A, because amplitude is a positive value. So if you happen to have your amplitude is -6, the amplitude would just be 6, okay? The final thing I got to mention is that I'm just thinking of here, sometimes instead of using x, and you might have done this, you know in trigonometry, sometimes we use the Greek letters, right? So instead of saying maybe y equals sine of x, you might see this, y equals sine of theta. It's the same thing. They're just using theta instead of x. It's the exact same thing. We graph it the same. So if I'm making a table of values and I go x, y, or if I'm making a table of values and I go theta, y, it makes no difference. It's the same thing. So this here might be a theta also, right? That's all. Or some other Greek letter. Theta is just the most popular one to start with in trigonometry. All right, so there's all the main little points we need. And let's actually just try doing some and then seeing how this all pans out as we do it. Okay, I'm just going to walk through a couple examples. Now, the first thing is our graph. What are we going to put on our x scale? The y scale is fine. The y scale can just be numbers 1, 2, 3, 4, 5. But our x scale either has to be in degrees or in radians. Now, on this graph, I already have the radians drawn on below here, okay? So I'll just write rads for short, or rad really is short for radians. Let's write in the degrees because that's what we're more used to. So what we can do is write on top what the degrees are. So pi over 2, that's 90 degrees. Pi, that's 180. 3 pi over 2, that's 270. 2 pi, that's 360, right? That's a full circle, and then you can keep going. So my graph goes into the negatives, goes in the positives. This is the graph I'm basically going to use for everything. We can change up the scale, but for this week, we'll just work with these, okay? All right, so let's graph y equals 2 sine x minus 1. So what we need to do first is draw out the graph of, again, x and y, or maybe it's theta, right? Because we could change this and I could go, okay, it's theta instead of x. It just depends on the textbook. Some like to do it this way, right? So if you run into that, it's the same thing, x or theta, okay? So I'll just put it back to, well, you know what? I'll leave it as theta. It seems like more textbooks like to do that now, but it doesn't really matter. All right, so here we go. Let's start with our x values. So we're gonna have 0. Let's do the degrees first. Everyone's probably used to that. 90 degrees, these are the key points we need to know. 180, half of a circle, 270, 3/4 of a circle, and then 360. But get used to, I want you to also write the radians next to it. Get used to it, okay? Because it's really important. So 0 radians, pi over 2, 2 pi over 2, which is pi, 3 pi over 2, and then 4 pi over 2, which is 2 pi, right? I'm just counting by pi over 2s. Every pi over 2, right? 1, 2, 3, 4. All right, what are the y's? Just look back at those tables. We already drew them, right? 0, 1, 0, -1, 0. And if you forget, just punch in your calculator. What is sine? Again, if you don't remember these, just go, well, what's sine of 0 degrees, right? You'll get out 0. What's sine of 90 degrees? You'll get out 1, and so on and so forth. What's sine of 180 degrees, right? You'll get out 0. So that's how I'm getting these numbers, 0, 1, 0, if you do sine of 270. So if you forget them, you don't memorize them, that's okay. There you go, right? And then finally, sine of 360, right? You would get out 0. Now, again, that's if you're using degrees. If you're using radians, you'd have to make sure your calculator is set to radians and then punch in 0, pi over 2, pi, so on and so forth. Okay, so there's our starter table. All right, so now we are only going to do transformations on the y. So I'm not going to write the x's out a bunch of times, but I am going to do it in steps here so we can see everything that's going on. Okay, and then you might realize there's some real shortcuts you can take, and I don't mind if you take the shortcuts, okay? So the x's or the thetas, x or theta, are going to stay the same. I'm not going to write anything. We're just going to leave them where they're at for now. Remember, we're doing no horizontal transformations for now. So what do we got to do first? Well, remember what we're supposed to do is we're supposed to go a times y, right? We multiply all the y coordinates by a. Well, what's a? A is 2, right? So we're going to go 2 times all our y coordinates. Don't forget, that's our amplitude. So the amplitude, if someone says, what's your amplitude? Let's identify all this stuff because it's important. Amplitude. Remember, the amplitude is the absolute value of a. So it means if it's negative, make it positive. Well, 2 is not negative there, so it's just 2. There's our amplitude. All right, so let's multiply all the y coordinates by 2. So this becomes 0, right? 2, 0, -2, 0. So everything's just 2 times as high. All right, let's do the y coordinates. Let's do the vertical displacement or vertical transformation or vertical translation, right? All these different names. And that is c. C equals -1. So what are we going to do? We're going to take our y's from before and we're going to add c. So in this case, 2 times y, we're going to -1. So 0 minus 1, 2 minus 1, 0 minus 1, negative 2 minus 1, 0 minus 1. So notice how our middle was at 0, now it's at negative 1. All right, so let's graph this thing. Let's see what it looks like. I'm going to graph the original, first of all, in black, and then I'm going to graph this second one in green. The third one here. We can even graph all of them. So what do you got to decide, though, when you make your scale? You want to make sure your y's fit all these numbers in. So notice I didn't write a scale in, so I can really stretch it out if I want. I think I can fit like +1, +2, +3, +4. So I'm going to go every other one. It's up to you. If you just want to go every one, that's fine. I'm just going to stretch it out a bit so you can really see. So here's 1, 2. So I never do my scale till I get to the end, and then I decide what my scale on my y-axis is going to be. All right, so the original one, 0, 0, right there. And then it went 90 degrees. We're at 1, 180 degrees, back at 0. Then we're down -1. Oops. And then we're back at 0. So if I draw this one, there's the original. So that's this guy. That's this. Y equals sine of x, or sine of theta. That's the first one. That's the first table. Second table, what did we do? We multiplied everything by 2. So if we want to draw this in, right, what's going to happen? Everything's going to be 2 times as high. So 0 over 0 up, same spot. 0 over 2 up, 0 over 2 up here. And then 180, back at 0. 270, we're at -2. And then back at 0. So notice how the amplitude, right, got bigger. So now it's twice, all the y-coordinates are twice as high or twice as low. So my amplitude is this distance from here to here, right? It's 2, or from here to here, it's 2. All right, let's draw the final graph, which is, so let me just write down what this graph. So if this graph would just be y equals 2 sine theta, or 2 sine x. Okay, now the final graph includes all the transformations. Y equals 2 sine theta minus 1. Okay. So what are we going to do? Shift everything down 1. So all that happens is we go down 1. This guy's going to move down 1. This one's going to move down 1. This red point's going to move down 1 and down 1. So you can look at your table for those, right? -1, 1, -1, -3, -4. So when I draw this, it looks like this. There we go. All right, so the green one is our final transformation. Now what I want you to do is draw in the equation of the axis. What's the equation of the axis? Okay, so let's write that down here. The equation of the axis. That's the middle of the graph. And it's a pretty easy equation to find because it's just y equals c. So ours is a horizontal line, y equals -1, right? That's a horizontal line. If you go back to the first lesson on this stuff, you'll see we talk about that, right? Horizontal line. Okay, so just draw that horizontal line, and we want to see where that is when we're doing our work here. So it's at -1, and that's the middle of my graph right there. And make sure you always label it, right? There you go. Okay, so that's it. So the vertical transformations are pretty easy, right? There really isn't much to it. It's simple. It's the horizontal ones that get a little messy, but you can see they're pretty simple. There's all the original, and then the stretch, and then the shift down, right? All right, what else do we want to mention? Now, this so far, I've only drawn it between 0, right? We'd say theta is between 0 and 360 if we're talking about degrees. Or if we're talking about radians, theta is between 0 and 2 pi. Now again, theta can be x, so we could say the x coordinates if we want instead, if we want to change that to x, right? It's the same thing. So I've only drawn one cycle. This is one period or one cycle, right? So one cycle of it is from here. Now the period, if someone says, well, what's the period? The period is how long does it take to complete one cycle. So the period is, for everything we're doing this week, is going to be, if it's in degrees, it's going to be 360 degrees. If it's in radians, it's 2 pi. Okay, so it just depends on what we're talking about. We want to get comfortable kind of going back and forth between the two. 2 pi is a full circle, it's 360, right? Now, what can happen is we could come along and say, hey, I want you to extend this. So what might happen is, it might say, let's just go a little farther here. What if the question said, instead of drawing it between here and here, what if it said, I want you to draw it between -2 pi and 4 pi? You might say, well, what the heck is that? Let's convert it to degrees, right? Well, how much is 2 pi? That's 360. So from -360, how much is 4 pi? Well, every 2 pi is a full circle, is 360. So this is 2 circles. So in other words, it's going to be 720, right? That would be right there. There's 720. There's negative 360. We could write everything in if it helps, like negative 90. You can write them in on top, and I'm sure it will help, and it's a good idea. So don't feel bad about writing these in, right? And then going this way, I could just keep adding 90. 360 plus 90 is 450. 450 plus 90 is 540. And then you get to 630. And then 720. So there you go, right? So what if we want to extend that? So I'm just going to extend the green graph for now. So all we got to do is keep the pattern. Starting from the top, what do? We go negative 1 to 1 to 0 to negative 3 back to negative 1. Well, where's the next point going to be if we keep this going? We're going to be over here, and we're going to go up to 1 again. And then we're going to take another 90-degree step and come back down. Another 90-degree step, come back down. Another 90-degree step. There we go. So I've drawn this. I've extended my graph to 720 or 4 pi. Well, we also want to extend it to negative 2 pi or negative 360. So just keep the pattern going, right? We just need to go in reverse here. So we're coming up, down. We should be heading down here, right? So we're going to go down to negative 3, back up to 180, back up to positive 1, and then back down to, I almost drew it off the graph right there. So keep your pattern going, right? Up, down, and there we go. So if I take away, I'll see if I can just kind of erase some of the red and black graph there. I won't try and get rid of everything. It'll be too messy, but you get the point. Getting rid of some of those numbers by accident. All right, good enough. There you go. There's the graph of just y equals 2 sine minus 1, right? Drawn for the domain of between negative 360 and 720, or negative 2 pi and 4 pi. Okay, so that's about as far as we want to go. I'll do another one of these. I'll just make another one up, and we'll kind of extend it and do the same thing, okay? So let's just try one more. Okay, so I've got one here, y equals negative 5 cos theta plus 3. And I'm going to say, I want to draw it between, so I'm going to say 4. So this is telling you where to cut it off, because it can go forever in both directions. So what we're going to say is, let's draw this for negative pi, less than or equal to that guy, to, let's do it to 3 pi. Let's draw it between there. So I'm just kind of picking. Look, there's negative pi. There's 3 pi. There's where we want to cut it off, right? Well, what are those in degrees, right? Well, let's look at our unit circle, whatever it takes. Now, don't forget, let me just do a little mini lesson too. How do you convert degrees to radians? We've done this before, but let's remind ourselves, or radians to degrees is probably what you want more, right? My bad. So let's just remind her. I'll do a little mini lesson. This will help you out, right? Tons. How do you convert rad to degrees? Well, it's pretty easy. Take your radians, okay, whatever you got, and you're going to times it by 180 divided by pi. That's it. So like, let's say this, let's take negative pi and let's convert that. So I'll just write it all down here and then I'll erase it when I'm done. So if someone says, oh, negative pi, and I'm like, well, what the heck is that in degrees? I'm going to times that by 180 over pi. Well, what's going to happen here? The 2 pi's cancel out. I have negative 1, right? That's a 1 and a 1. I got negative 1 times 180. Oh, that's negative 180 degrees. So if I want to write that up here, I'm going to write in purple. That would be negative 180. Okay, cool. Less than or equal. So again, right? Think about it. We can also count like that. Right there would be 180. And this is 90. Negative 90, sorry. Negative 180. This is 0, right? This is 90. This is 180. This is so on and so forth, right? Look at your unit circle again. All right. So let's say we want to look at the high end here, and someone says, all right, convert 3 pi. Oh, I don't know what 3 pi is. I want to convert it. Okay. All we're going to do is times it by 180 over pi. Well, all that ends up happening is, look, the pi's cancel out, and you just go, what's 3 times 180, right? 3 times 1 is 540. Oops, wrong pen there. There we go, 540. So this would be 540. Now, if I'm not sure, look, I can also, I have my graph set up for you guys today. We're just counting by 90s, right? 90, 180, 270, 360. That's 2 pi. That's a full circle, right? Plus another 90 is 450. Plus another 90 is 540. So look, there's my 3 pi, 540, right? Okay, so that's the first thing. Write this down somewhere. Get it tattooed. You know, there you go. So if you're stuck, the nice thing is any of these questions, even if they give you the entire question in radians and you're like, I don't want to work with radians, you can just convert the numbers they give you to degrees and do everything in degrees, okay? So it shouldn't be a big panic or excuse with, I don't know, work with radians. Just convert everything to degrees using this. Take your radians, times it by 180 divided by pi. Eventually, if you continue in math, those of you who are interested in learning it, you will get better at it. All right, so we're going to do cos now. So let's start with our starting graph here, right? Here's cos. Y equals cos of x or cos of theta, whatever. So if you get a handout that says x instead of theta, it's the same thing. All right, so theta or x and y, right? I hate using theta. I just use x and y for everything. It drives me nuts. I don't know why. Like we're doing trig, all of a sudden we have to use a different thing. You know, it's x and y. It doesn't matter, right? All right, so 0, 1. Oh, sorry. Let's do it in degrees first. 0, 90, a quarter of a circle, right? Half a circle, 3/4 of a circle, and then a full circle. And we can also write in the radian measures next to it because we really should get good at knowing those and really learning them. Let me just shift this over just a titch. Okay, so 0 degrees is 0 radians, right? 90 degrees is pi over 2. This would be 2 pi over 2. So we're counting by pi over 2s. 1 pi over 2, 2 pi over 2, which reduces to pi, 3 pi over 2, which I can't reduce, and then 4 pi over 2, which I can reduce to 2 pi. So all I'm doing is counting by pi over 2s, right? All right, so there you go. That's a full circle. So what are our y's for cos? This is the only thing that's different than sine. Everything so far has been identical, except for you start at 1 going down. And again, if you forget, you can punch this right in your calculator. So even if you're on a test someday and you're like, I don't remember, I didn't memorize this table, like just punch in your calculator. Okay, what is cos of 0? Right? Make sure it's in degrees or radians, whatever one you're using. If you do cos of 0, guess what you'll get out? 1. What's cos of 90 degrees? You'll get out 0. What's cos of... So this is all, you don't have to memorize it to know how to do it. You just got to know how to do it, right? And so on and so forth, right? So this is how you can get all these numbers here. Okay, cool. All right, so anyways, back at it. Here we go. Let's get this junk cleaned up. All right, so let's do the first thing. What's the first thing? That is going to be our vertical stretch. So we have y equals -5 times cos of theta, right? That's our first one. Let me get all this other junk out of the way so I got some room to discuss stuff. All right, so we're going to have a vertical stretch by a factor of 5. So remember all those things, right? A is equal to -5. So what does that tell us? We have a vertical stretch, right, by a factor of 5. If we need to describe it, same stuff from before. Okay, and the negative tells me that there's a vertical reflection. So this thing's going to flip. All right, you know, before we even draw that, maybe we should draw the original one on here first. I'm just going to make it go by ones because I think this graph's going to get really stretched. So I'm going to make every square 1 unit. So like 1 and -1 and so on and so forth, right? So if I graph this, the original one's going to look like this. I'm kind of drawing on my stuff here. 0, oops, I'm drawing sine. Starts at 1, goes down to 0, goes down to -1, comes back up to 0, comes back up to 1. Now I've really squished it here and I got the degrees written in, so it's a little bit hard to tell, but there's cos. That's one cycle of cos, right? If we only draw cos from 0 to 360, there's one cycle, okay? Because after that, it just repeats, right? Over and over and over again. It's the same thing. All right, so what do we got to do? Let's move back to doing our stretches here. So we're going to leave the x's the same. We're not going to mess with them. We're not doing horizontal, so we're going to multiply the y's by a, so -5 times our y coordinates, right? So this is now -5, this is 0, this is +5, this is 0, this is -5. So if I draw this guy, we're going to have this thing stretched out quite a bit. So right, 1, 2, 3, 4, 5. So there's where +5 is, and -5's 2, 3, 4. There we go. There's -5. Okay. So if I draw this, it's been flipped. So now we're starting at -5 when that's 0, and then we're coming up to 0, and then we're going up to +5, back to 0, and then back down to -1. So it's going to look like this. Don't draw like a V. Everyone does this and goes, there it is. Look at this. This curves like this. Now it's been flipped and stretched, so it has to curve like this, and then curve up. Not the greatest, but not too bad. That curve down, and then curve like that. So there's what one cycle of cos looks like. Okay. Now, what's the next thing we got to talk about? Well, I guess we should mention the amplitude, because remember our amplitude is a. So I'll just kind of keep a little list down here of our amplitude. All right, so our amplitude, remember, is the absolute value of a. So the absolute value of -5 is 5. So remember, that's the distance from the middle to the top, 5 units, or the middle to the bottom, 5 units. Okay, so there we go. Pretty easy, that. All right, the next thing we want to talk about is our vertical translation, or vertical displacement, as it's often called in sinusoidal functions. So Remember, we take AY and we're going to add C. So C in this case is 3. So we're going to go to negative 5 times Y. We're going to add 3 to everything. And if I write this function out, this would be the full function that they wanted us to graph in this question, right? There we go. Okay, so there he is. So all we got to do is add 3 to all our Y's. So negative 5 plus 3, we're down at negative 2, 3, 8, 3, negative 2. So everything's moved up. So let's also identify the important stuff here. So what do we say? C is 5. Well, what does that tell us? There's a vertical translation, right? Or they like to use the word displacement, okay? Up 3 units, okay? It also tells us, remember the equation of our axis. The equation of the axis. That's the middle of our graph. So that's y equals c. So in this case, since we moved everything up 3, now it's y equals 3. So I'm going to draw that line in first, actually, just get that right out of the way. All right, so 1, 2, 3 units. There we go. We're just going to make every square worth 1 here. There we go. So now there's the new middle of my graph. It used to be at y equals 0. Now it's moved up. Oh, it's going to drive me nuts. It's a little bit off the line. There we go. No, it's even worse. Yeah, that's going to have to do. There we go. So there's y equals 3. All right, so now, like we were saying, let's plot these points. All right, so when we're at 0, I'll just write in the x, right? When we're at 0 degrees, we're at negative 2. 0 degrees, we're at negative 2 right there. So I'm just, if you were like, wait, what are you using for x? I'm just using the original ones. That's why I didn't write them. It's the same stuff over and over again, right? At 90 degrees, right, we're at 3. So we're all the way back at our middle there. At 180 degrees, we're at 8. So I'm going to have to go up a little bit farther. So what do we got here? 5, 6, 7, 8. There's 8 up there. All right, we're at 8. At 270 or 3 pi over 2, we're at 3. Back down in our middle. And finally, at a full cycle, a full circle, we're back at, what are we at? Negative 2. All right, so there it is. Now remember, don't just connect them with a straight line. It curves like this, right? Remember, we flipped it. So the curve flipped. There we go. All right, so there's one cycle of it. Now I'm going to get rid of the other ones I drew. I drew those in so we could really get a good feeling of what this is supposed to look like. But I'm going to get rid of the red. There we go, the best I can. I don't want to delete all these dots or I'll ruin everything. All right, so there's our final graph, but that's only one cycle. Remember at the start I said I want you to draw it between negative pi and 3 pi, or negative 180 and 540. So we just need to continue the pattern. So let's move in the positives, right? What are we at? Negative 2, 3, 8, 3, negative 2. Now we're going to go back up to 3. Oops, did I miss a point? Nope, I'm good. 3, and we want to cut it off right here, it says, at 540. So there's where I'm going to cut it off because it said stop it there. So again, I just kind of arbitrarily made up that range or that domain, right? But that's where it wants us to cut off. It says 3 pi on the one side. Okay, cool. If it helps, you can even draw in like a vertical line to say that's where you're cutting it off, which I do sometimes in class when I'm doing it, just to say there's our cutoff, right? There is x equals 3 pi, or x equals 540 degrees. All right, now it wants us to go all the way to negative pi. Well, that's right here. So I'm going to draw, I like to draw these little walls in. I should use a ruler. But I do that a lot in class just to say, hey, that's where I am going to be cutting this thing off, okay? So there is x equals negative pi. All right, so we just need to continue it. So we shouldn't be going down, right? What's the next step? It's to go back up, right? If we're reversing it, right? Going backwards, we go to here, we're back here, and then we're back at the top. So we want to maintain that pattern. So remember, sine and cos are actually the exact same wave. They call it, a smooth wave, a sinusoidal wave. They're exactly the same. They're just shifted a little bit. So there you go. Like if you lay that over a sine one, they look exactly the same. They're just shifted a bit. That's it. One more time, because it comes up a lot where things say, well, what's the period? Remember, the period is how long in the x does it take to finish one cycle? Well, for everything we're doing right now, it's 360 if you're talking degrees, or 2 pi if you're talking radians, okay? So right now, that's one cycle like we drew here. From here to here was the first cycle, and then we just extended it, right, to whatever the question said to extend it to. All right, so that's as far as you're going to go this week. I want you to start, basically follow what I did here and graph these, okay? Now, the nice thing is, shortcut-wise, think about it. All we did, once you know where your x's are, all we did is, what's the high point, right? What's the low point? What's the middle? The middle is just C, right? 3. There's the middle. I can draw that in. Well, don't I just add and subtract 5 from that? Isn't that how I get to the top? 3 plus 5, right? That's the top. That's my peak, right? 3 minus 5, right? My amplitude. Isn't that the trough or the bottom? So when you're drawing these, you can do them really quickly if you realize, oh yeah, wait a minute, I'm just starting in the middle, right? I'm adding 5 and subtracting 5 from the middle, my amplitude, to find the top and bottom of my graph, and then you can kind of fill in from there. So there's a little tip, just something to think about to make sure you're doing it right. Give the questions a try, and don't be afraid to ask some questions. Thanks, guys.